大家好，欢迎回到宋书新语。在过去一年啊，英伟达可以说出尽了风头，特别是从去年到今年，随着生成式 AI 时代的到来啊，作为最核心的供应商啊，英伟达的这个 GPU 啊，可以说占尽了风头啊。现在呢，它的竞争对手来了 ，AMD 啊推出了 MI300X 啊，它可以运行多达800亿个模型。那昨天呢，美东时间6月13号周二啊 ，AMD 举行了新品发布会啊，就是介绍了 AMD 最先进的这个产品 GPU， 就是 Instinct MI300啊。AMD 的这个 CEO 大家知道，就那位老太太 Lisa 苏啊，译过来叫苏姿丰。那么苏总说呢，在 AMD 的产品里边啊，是全球首款针对 AI 和高性能计算的加速处理器 APU Accelerator 啊。APU 不是 CPU 了啊，加速器在13个小芯片中遍布了1460亿个晶体管，所以这个技术呢，可以说啊是 AMD 的一个里程碑式的产品，所以他们举行了一个 AMD Instinct MI300A 的发布会，它主要是针对这个大语言模型 LLM 的协议啊进行优化，拥有192G 的 HBM3 的内存。5.2TB 的每秒的带宽和896G 的 Infinity Fabric 带宽，所以呢，将这1500多亿个晶体管啊集成到12个5纳米的小芯片中。所以这里边啊，AMD 这次来说，可以说他们意味着呢，在它的产品上可以运行比英伟达更大的模型啊。在发布会上啊，这个 Lisa 苏呢还这个介绍了 MI300X 呢可以支持400亿个参数的Hugging Face AI 的模型运行，并且呢让这个 LLM 的这个大语言模型呢写了一首关于旧金山的诗啊，这是全球首次在单个 CPU 上运行这么大的模型啊，单个 MI300X 就可以运行一个参数多达800亿的模型。大家知道在过去啊ChatGPT 啊，但是它的模型很大，它是运行在10000个英伟达的 GPU 上。那 LLM 呢，就是 LLM 如果运行在 AMD 的 CPU 上呢，以后呢，可能呢 APU 哈可以使用更少的 GPU 啊，它就是这个 APU 带来的这个好处。那关于这个发布会的详细情况啊，很长，大概1分40多秒啊，我把前面剪掉，给大家做一期 react 啊，就是同步观看这个视频。我加上了中文和英文字幕啊，这里边呢没有怎么做有效的修改，可能有一些错的字，大家应该能看懂的啊。好的，我们一起来看一下这个视频。
All right, good morning, good morning. How's everyone doing this morning? It is so exciting to be back here in San Francisco with so many of our press and analysts and partners and friends in the audience. And welcome to all of you who are joining us across the world. We have a lot of new products and exciting news to share with you today, so let's go ahead and get started. At AMD, we're focused on pushing the envelope in high performance and adaptive computing to create solutions to the world's most important challenges. From cloud and enterprise data centers to 5G networks to AI, automotive, healthcare, PCs, and so much more, AMD technology is truly everywhere, and we're touching the lives of billions of people every day. Today, we're here to talk about our newest EPYC data center processors, our upcoming Instinct accelerators, and our growing AI software ecosystem. Now, taking a look at modern data centers, what you really need is the highest performance compute engines across the board. Today, we lead the industry with our EPYC processors, which are the highest performing processors available. We also offer the industry's broadest portfolio, which allows us to really optimize for the different workloads in the data center. Whether you're talking about Instinct GPU accelerators built for HPC and AI, or you're talking about FPGAs or adaptive SoCs or smart NICs and DPUs from our Xilinx and Pensando acquisitions. What we'll show you today is how we bring all that together and really expand our portfolio with our next generation data center and our AI offerings. Now, since launching EPYC in 2017, we have been laser focused on building the industry's best data center CPUs. EPYC is now the industry standard in the cloud. given our leadership performance and TCO across a wide range of workloads. Every major cloud provider has deployed EPYC for their internal workloads as well as their customer-facing instances. Today, there are more than 640 EPYC instances available globally, with another 200 on track to launch by the end of the year. Now, looking at the enterprise, EPYC adoption is also growing, and especially for the most demanding and technical workloads. Whether you're talking about financial services, or telecom, or technology, or manufacturing, or automotive customers, and many, many more, they're really choosing EPYC based on our performance, our energy efficiency, and our better total cost of ownership. And that momentum is just growing as we ramp our 4th-gen EPYC Genoa processors. Genoa features up to 96 high-performance 5-nanometer Zen 4 cores. It has the latest I/O that includes PCI Gen 5, 12 channels of DDR5 memory, and support for CXL. We launched Genoa actually last November, and it had leadership performance and efficiency. And since then, there have been other products that have come to market. But if you look today, Genoa is still by far the highest performance and the most efficient processor in the industry. So let's just take a look at some of those metrics for Genoa. Starting first with the cloud, integer performance is key. Using spec int rate and comparing to the competition's top of stack, EPYC delivers 1.8 times more performance. Looking at the enterprise, if you look across Java workloads or virtualization or ERP workloads, 4th-gen EPYC is up to 1.9 times faster. And perhaps the most important piece is in modern data centers, energy consumption has become just as important as overall performance. And when we designed Genoa, we actually designed that with that in mind. The idea that, yes, we want leadership performance, but we must have best-in-class energy efficiency. And that's what 4th-gen EPYC does. We deliver up to 1.8 times more performance per watt than the industry, compared to using the industry standard spec power benchmark. And what that means is that Genoa is by far the best choice for anybody who cares about sustainability. So when we talk to customers, many of them are telling us, actually, they need to refresh their data centers, and they really need to consolidate and get a better footprint and get a better operating cost. This is actually the perfect place for Genoa, and it really shines for these types of consolidations. Now, looking at AI, we're going to talk about GPUs shortly, but actually today, the vast majority of AI workloads are actually being run on CPUs. And Genoa is also the best CPU for AI. The best way to look at AI performance is actually to look at a broad set of end-to-end workloads. And so we use the industry standard TPC-XA benchmark that actually looks at end-to-end AI performance across 10 different use cases and a host of different algorithms. And what we see in this case is EPYC is 1.9 times more performant than the competition. Now, you can see I'm tremendously excited about Genoa and all of the applications that our customers are running on Genoa, but it's best to hear directly from our partners. So I'm really excited to introduce our first guest, one of our most important cloud partners, to talk about how they're deploying Genoa in the public cloud. Please welcome our good friend, AWS Vice President Dave Brown. Dave.
Hey, Lisa.
It is so wonderful to see you. Thank you so much for being here with us today.
Great to see you as well. Thank you.
Yeah, we have been, so much has been going on. You know, we've been on this long journey and partnership together. Can you talk a little bit about our partnership?
Absolutely, Lisa. And thank you for having me, and thank you for the opportunity of being here today. I'm excited to talk about our partnership and how AWS and AMD are continuing to collaborate to advance cloud technology for our customers. At AWS, we're constantly innovating on behalf of our customers and have built the most reliable and secure global cloud infrastructure with the broadest and deepest portfolio of instances to support virtually every type of customer workload. AMD and AWS have been on a journey together since 2018, when AWS was the first to introduce the AMD EPYC-based instance in the cloud, delivering 10% cost savings over comparable x86 EC2 instances. And as customers used and benefited from these instances, they requested additional AMD-based instance types to run a broader set of applications. And together, we have introduced over 100 AMD EPYC-based Amazon EC2 instances for general-purpose, compute-intensive, and memory-intensive workloads. And just last year, we introduced our first instance optimized specifically for high-performance computing-based AMD processors, HPC6A. And that delivered up to 65% better performance over comparable EC2 x86-based compute-optimized instances for workloads such as computational fluid dynamics.
Dave, we love the work with your team. I mean, it has been such a journey over all of these years, and we love the 100+ instances. Now, the breadth of your offerings is amazing. Now, we always talk about what can we do with our joint customers, and how do they benefit from our technologies? So can you tell us a little bit about customers?
Absolutely. So we have a broad range of customers, and they've benefited significantly from the cost savings with AMD-based EC2 instances. A few examples of how enterprise customers have invested these cost savings into innovation to improve their businesses include TrueCar, a digital automotive marketplace, one of my favorite tools. They sought ways to operate more efficiently and increase development velocity so they could invest the money saved into innovating for car buying experience. And TrueCar optimized its AWS cloud infrastructure by up to 25% from a combination of choosing the AMD instance family for its core infrastructure, as well as right-sizing instances with AWS recommendation tools. And Sprinkler, another customer, is a purpose-built web platform for businesses to manage customer experiences on modern channels. With the scale at which Sprinkler operates, it is to optimize its robust architecture for cost and performance. Sprinkler has been an early adopter of our first-generation AMD-based EC2 instances for general-purpose workloads, our M5A instance. And when they moved to Amazon EC2 M6A, the next generation, Sprinkler saw 22% faster performance and 24% cost savings over the previous generation. And then in the HPC space, DTN, they run weather and data models that deliver sophisticated, high-resolution outputs that require continuous processing for vast amounts of data from inputs across the globe. DTN uses Amazon EC2's HPC6A instances, powered by AMD's EPYC processors, to run computer-intensive HPC workloads. And through the agility, elasticity, and efficiency of running HPC workloads on AWS, it has effectively doubled its high-resolution global weather modeling capacity from 2 times a day to 4 times a day.
I love what we're doing together with customers. It's really great to hear those examples. I think both AMD and Amazon, we really share this passion for enabling our customers to do more with our technology. Now, I'm even more excited, Dave, about what we're doing next together. So can you talk a little bit about what's next for our partnership?
Absolutely, Lisa. Well, one of the things we continue to see is increasing demand from customers to run workloads faster while getting better price performance in AWS. And to help address customer needs, we're building new EC2 instances enabled by the unique combination of the 4th-generation AMD EPYC processors together with the AWS Nitrous system. Now, the AWS Nitrous system is the foundation for every single EC2 instance, enabling us to deliver performant, secure, and efficient infrastructure. And by combining the 4th-generation AMD EPYC processors and the AWS Nitrous system, we've unleashed the full capability of the next-gen AMD processors and deliver a significant leap in performance for our customers.
Yeah, look, we're so excited about what we're doing together with you, with Genoa, with Nitro, with all of your resources at AWS. Let's talk about what that means for customers.
Well, today, we are very excited to announce the preview of Amazon EC2 M7A general-purpose instances powered by the 4th-generation AMD EPYC processor. And based on our spec... They're
kind of excited about that,
So are we.
Yeah.
And based on our spec-in benchmarks, M7A has been designed to provide the best x86 performance and price performance per vCPU within the Amazon EC2 x86 general-purpose instance family. M7A instances offer a major leap in performance with up to 50% more compute performance than M6A, the previous generation. We think workloads, including financial applications, application servers, video transcoding, simulation modeling, they would all benefit from the M7A instance. M7A instances also offer new processor capabilities such as AVX3512, VNNI, bfloat16 to enable customers to get additional performance and bring an even broader range of workloads to AWS. And as I mentioned earlier, M7A instances are in preview today. Customers can sign up for the preview and with general availability coming in Q3. And of course, AWS will be bringing Genoa to more of EC2 instances so our customers can do more with this new level of performance over time. Elisa, we're also very excited that AMD will be using these instances for your own workloads.
Yeah, I mean, absolutely, Dave. By the way, did you guys hear that he said 50% more compute performance on M7A? I mean, it's just amazing gen-on-gen performance, and we're so excited that we're going to see Genoa throughout EC2. We truly appreciate the partnership with AWS, Dave. You know, you're such an important partner for our own IT environment as well. So we're using AWS today for our data analytics workloads, and we appreciate all of your flexibility and capabilities there. But with the new Genoa expanded instances, we're going to expand our partnership to include some of our highest performing technical workloads, such as EDA. So thank you.
Fantastic. Well, Lisa, it's been really great to be here with you to kick off this event. We're excited about the performance and the price performance benefits we're able to deliver for our customers, and I can't wait to see how our joint customers will innovate with this technology.
Thank you so much, Dave.
Thank
Thanks
you,
for
Lisa.
being here, and thanks for
very
your
much.
partnership.
Thank you.
We're super excited with the new M7A Genoa instances reaching public preview, and we really believe that this is a step function improvement in performance that you can get in the public cloud. We're looking forward to delivering even more capabilities for our customers with these new instances. And when you look across the industry, we're actually really pleased with the response that we're getting on Genoa based on the leadership and also delivering across a broad number of general purpose server workloads. So I also want to say today that Oracle is announcing today also new Genoa standard, HPC, and dense I/O instances that are expected to enter general production starting in July. Now, I'll say overall, Genoa is ramping very nicely, and you'll see a number of other public instances and customers coming online over the coming weeks and months. But what I did say earlier is that data center workloads are becoming increasingly more specialized, requiring optimized computing solutions across CPUs, DPUs, and of course, AI accelerators. And that's what makes AMD special. Our breadth of our data center and AI compute portfolio actually provides a significant advantage because you can use the right compute for the right workload. So now let's talk about cloud-native computing. Cloud-native workloads are actually a very fast-growing set of applications that are really, let's call it, born in the cloud. They're designed to take full advantage of new cloud computing frameworks, and they run as kind of like microservices. So you split up sort of large amounts of code, and you put them into smaller processes, and then they can be scaled independently to enable 24/7 uptime. The optimum design point for these processors are actually different than general-purpose computing. They're actually very throughput-oriented, and they benefit from the highest density and the best energy efficiency. So all of these factors actually drove the development of Bergamo. Bergamo is actually our first EPYC processor designed specifically for cloud workloads. So let me tell you a little bit about Bergamo. Bergamo leverages all of the platform infrastructure that we already developed for Genoa, and it supports the same next-gen memory and the same I/O capabilities, but it allows us, with this design point, to expand to 128 cores per socket for leadership performance and energy efficiency in the cloud. Now, I'm very happy to show you, Drew, can I have my chip, please? As you guys know, I love my chips. Our chips. I am very happy to show you Bergamo. This is our new cloud-native processor, and what we have here is there's actually a new compute die. So the compute die is different from Genoa, using our triplet technology. Each of these 8 compute dies has 16 of our Zen 4 cores, and then we use the same 6-nanometer I/O die used by Genoa in the center. Thank you. So let me talk a little bit about how we do this. If you take a look at the core, the Zen 4C core is actually an enhanced version of the Zen 4 core. It's actually a great example of our modular design approach. When we originally designed the Zen 4 core, it was actually optimized for the highest performance per core. Zen 4C is actually optimized for the sweet spot of performance and power. And that actually is what gives us the much better density and energy efficiency. And the way we accomplish this is that we actually start from the exact same RTL design as Zen 4, and that gives us 100% software compatibility. And then we optimize the physical implementation of Zen 4C for power and area, and we also redesigned the L3 cache hierarchy for greater throughput. So if you put all this together, the result is a design that has 35% smaller area and substantially better performance per watt. Now, from a product standpoint, what does this mean? What it means is the only real difference between Genoa and Bergamo is the CCD core chiplet. So we use the same socket, we swap out the Genoa CPU chiplet, and we put in the Bergamo CPU chiplet. And what you have is each of the 8 compute chiplets on Bergamo contains twice the number of cores as was on Genoa. And that's how we get to 128 cores per socket. But importantly, as I said, it's fully software compatible, and it's also fully platform compatible with Genoa. And what that means for customers is they can easily deploy either Bergamo or Genoa, depending on their overall compute needs and their overall workloads. And so we really tried to leverage the overall platform investment in AMD. So let me show you some of the performance metrics on Bergamo. If you compare Bergamo to our competition's top of stack, what you'll see is just incredible performance. We're delivering up to 2.6 times more performance across a wide range of cloud-native applications, whether you're talking about web front end, or in-memory analytics, or very heavy transactional workloads. And then if you look beyond that, in terms of looking at sort of the overall density and capability, Bergamo, again, is significantly better than the competition in compute density and energy efficiency. So what we see is more than double the number of containers per server, and 2 times the energy efficiency in Java workloads. Now, as you can tell, we are incredibly excited about Bergamo as well and the benefits it will bring to our cloud customers. So I'm happy to say that Bergamo is shipping in volume now to our hyperscale customers. And as I said earlier, I always like to talk about how customers are using our solutions. So to hear more about how one of the world's largest cloud companies plans to deploy Bergamo, let me welcome Meta's Vice President of Infrastructure, Alexis Björlin, to the stage.
Hi, Lisa.
Alexis, it's so great to see you. Thank you so much for being here.
It's wonderful being here. Thanks for having us.
Oh, absolutely. I mean, the partnership that we've had with Meta is just incredible. I mean, you guys are known for really pushing the envelope in hyperscale computing, and really combining not just the engineering leadership, but also the commitment to open standards, and frankly, running your infrastructure at scale for lots of applications and billions of people. So can you share a little bit about how we're working together?
Absolutely. So as you know, Meta and AMD have been collaborating on EPYC server design since 2019. These collaborations have been expanding over time with Milan, Genoa, and now Bergamo. We've worked closely to customize AMD's EPYC architecture to meet Meta's power efficiency and compute density requirements. These optimizations include all layers of the hardware and software stack, including Zen cores, SoC composition, firmware, kernel performance, telemetry, and software to deliver best-in-class performance per TCO for our compute infra. We've also shared our learnings around reliability and maintenance and have helped improve the EPYC to server designs for all hyperscale deployments, as well as you know, with all of our platforms, we open source the AMD Milan-based server design via the Open Compute project in the past, and we intend to do the same with our latest Bergamo generation high-volume servers. So we really appreciate working together with your team and your support on this.
Oh, absolutely, Alexis. You have a demanding team, let me say, but we love the work that we do with your team. I mean, the deploying infrastructure at your scale does present some unique challenges, and we learned a lot along the way. Can you talk a little bit about some of the work we've done together to address those requirements?
Absolutely. And as you know, we've deployed hundreds of thousands of AMD servers in production across our global data centers and fleet that are running thousands of workloads in service of WhatsApp, Instagram, Facebook, and across our product groups. We've also deployed AMD servers for video transcoding and storage systems and are using AMD CPUs on our AI compute platforms. So as you know, we've shared our workload learnings together with AMD and are working together as we address issues in scaling as they arise. And you're right, our scale is massive, and our scale and our generational ramp rate naturally strains our suppliers. But early on in our partnership, we had concerns about about AMD's ability to scale alongside us and meet our demand as we aggressively built out our data centers. But over the years, AMD has consistently delivered to meet these commitments, whether with your supply or your technical product roadmap innovations. We've been thoroughly impressed, and we've learned that we can rely on AMD to deliver time on time again.
Well, I really want to say, on behalf of all of our engineers, thank you for that. We work really hard. We truly value our partnership. And as we've said before, we love learning and co-innovating and co-developing with our partners. And some of the insights from your workload have actually helped us shape what Bergamo should be. So as one of the leading cloud companies, talk about Bergamo and how it fits into your plans.
Absolutely. We are incredibly excited to be preparing to deploy Bergamo as our next generation high-volume general compute platform for Meta. We're seeing significant performance improvements with Bergamo over Milan on the order of 2.5 times.
I'm sorry, did you say 2.5 times?
I did. And it offers substantial TCO improvements over Milan as well. So you make it pretty easy on me, Lisa. We love products that make both our technologists and our business teams happy. So building upon the core silicon innovation that AMD has enabled with Bergamo, we've partnered with AMD to add several other optimizations that help our workloads, including dense compute chiplets, the core-to-cache ratios, power management, and manufacturing optimizations that help us pack a high number of these servers into a rack and deliver rack-level performance per TCO improvements as well. So with the flexibility of your chiplet strategy for Bergamo, we're also pleased to have an I/O-intensive server option that we could leverage for HDD and flash storage platforms. So with our focus on enabling new products for our customers as well as capital efficiency, we're thrilled to unlock the benefits of Bergamo for our entire family of apps.
Well, again, thank you, Alexis. We are so excited to be working closely with you guys on Bergamo and really looking forward to not just deploying Bergamo, but also all that we'll do together in the coming years. So thank you again for joining me today, and thanks for your partnership.
Thanks so much, Lisa.
Thank you. We're so excited to hear stories like this where, Meta is deploying, broadly Bergamo, but most importantly, it's really broadly across the spectrum, including things like, Facebook, Instagram, WhatsApp that we use every day, as well as a number of other services. So as you can tell, we're incredibly proud of our 4th-gen EPYC family, but there's a bit more on the CPU side here. So to tell you more about how we expand our portfolio to deliver leadership in technical computing workloads, let me invite Senior Vice President and General Manager of AMD Server Business, Dan McNamara, to the stage.
Thank you, Lisa, and good morning, everyone. So 1 year ago, June, we rolled out our portfolio for EPYC around optimizing for different workloads. And we are super excited today to be delivering 2 new products. You just saw how we optimized 4th-gen EPYC for cloud-native computing with Bergamo. I'm going to spend some time showing you how we also optimized EPYC for a different set of data center workloads, technical computing. So for enterprises and firms that design and build physical products, engineering simulation is business critical. These companies need the top engineers in the industry supported by the best computing infrastructure. Companies that can move faster and more efficiently are differentiated by getting to market faster with more innovative and higher quality products and deliver this under a reduced OpEx budget. So with these goals in mind, we developed our 2nd generation of the AMD 3D V-Cache. Using the same integration of cache on core chiplets, but we're now supporting more than 1 gigabyte of L3 cache on a 96-core CPU. A larger cache feeds the CPU faster with complex data sets and brings a new dimension to processor and workload optimization. We first introduced this technology last year with Milan X, and now we bring it to 4th-gen EPYC, pairing it with the high-performing Zen 4 core that you just heard about. So today, I'm super excited to be announcing the availability of 4th-gen EPYC processors with AMD 3D V-Cache, codenamed Genoa X. We're delivering 4 new SKUs from 16 cores to 96 cores that are socket compatible with Genoa. Genoa X helps unlock the potential of the world's most important and demanding workloads in technical computing. Now, let's spend a minute on these workloads. From aircraft engines to the most advanced semiconductors, the rapid design and simulation of new products is an imperative in today's market. So while Genoa is the fastest general-purpose server processor in the market, Genoa X takes this performance to a new level for technical computing. And we're delivering all of this performance in conjunction with our partners, including digital manufacturing software from Altair, Ansys, and Dassault, and EDA software from companies like Cadence, Siemens, and Synopsys. We continue to work closely with these solution providers to create an optimized environment for our mutual customers. Now, let's take a look at some of the performance you'll see with these solutions. Let's start with some widely deployed CFD and FEA workloads. In blue, you see our highest core count Genoa X processor. In gray, you see the top of stack Xeon processor. What this data shows is that across these applications, the 96-core Genoa X processor delivers more than double the performance. And even when comparing processors with the same number of cores, the performance advantage remains very, very clear. So all this performance and software will be qualified on servers from the industry's top OEMs, and the platforms featuring Genoa X will be available next quarter. We sincerely appreciate our software and OEM partnerships as we increase the number of solutions to further serve the technical computing market with industry-leading performance and efficiency. So companies can also leverage the public cloud to run these simulations at top performance. So for more on that, I'd like to welcome Nidhi Chappell from Microsoft to the stage. Hey, Nidhi.
Thank you so much.
Thanks for joining us. So we have a strong partnership on technical compute across Azure, and I'd love for you to share with the audience about this partnership and our journey so far.
Yes, we've been on a mission together for some time now. So between Microsoft and AMD, we have a strong collaboration, and we have a joint goal. We wanted to make sure that we could deliver unprecedented performance for high-performance computing. As our enterprise customers wanted to accelerate their digital transformation, they wanted to make sure that mission-critical workloads like HPC could come along and really benefit from the scale and reliability and efficiency of cloud. So on that goal, we started our partnership back in 2019 with the introduction of our first HBVMs that featured first-gen EPYC processors. This was the time we ran 10,000 core simulation, and we thought, wow, we can run 10,000 cores in cloud. Then we upped our own game. In 2020, we launched our second-generation processor with the second-generation EPYC. We got into the top 10 supercomputers, and we started to really catch momentum in the market. We started building on our momentum, and in 2021, we had the third-generation HP series that went live to customers across the planet the day Milan was launched. And last year, we enhanced this even further, right? We actually announced that we would upgrade the third generation series with the AMD's 3D V-Cache, which provides 80% more performance for our customers at no additional cost. In just 4 years, we have delivered 4x performance for all of our HPC customers.
Thank you, Nidhi. So I must admit, with HBV3 and Milan X, we did have a lot of fun as two teams, and we also brought a lot of ISV partners and customers to the table, and it was really an exciting product. But I think you have some more exciting news to share today, so why don't you tell us about the future in Azure Compute?
Yes, absolutely. So today we are announcing the general availability of 4th generation of our HP series. And along with that, we have a new memory-optimized HPC virtual machines, which we are calling the Azure HX series. Now, both of our HBV4 and our HX actually feature the AMD 3D cache you were just talking about, and it also features that with our InfiniBand offering, which allows our HPC workloads to actually scale very well. Now, if you look at our 4th generation HB series, it offers 1.2 terabytes per second of memory bandwidth. You pair that up with the 2x improvements that we have seen in compute density, and now suddenly we can deliver 4.5x faster HPC workloads. This can be workloads like CFD, molecular dynamics, financial modeling, weather simulation, virtualized rendering of all sorts. And this is the beauty of actually combining the efficiency we get from AMD and the scale of cloud. That's on our HP V4. On the HX series, we are actually offering the ultra-low latencies, memory latencies, along with the 3D cache, and a massive 1.4 terabytes of system cache. Now, for some of the workloads that are very data intensive, like silicon design, structural analysis, this will deliver 6x performance, which is phenomenal. So for a lot of these customers, what this means is they can now fit a lot of their existing workflows, either on the same number of cores, fewer number of cores, and overall have a much better total cost of ownership because they save a lot on the software licenses. So really, 6x performance, a lot more savings, and you pair that up with best-in-class Azure Managed File System, Azure offerings on orchestration of our workloads, and end-to-end, our customers will see significant performance in the cloud.
It's just fantastic, Nidhi. So one of the things you and I talk about a lot is how do we enable our customers to solve their biggest problems? And I thought it might be a good opportunity to talk about some customers with HPV4.
Absolutely. The true test ultimately is the customer adoption. So I have 2 customers that I wanted to talk about today. One is Petronas. So as everybody knows, Petronas is a global energy company. They span hundreds of countries worldwide. And they're actually the first one to use the new Azure 4th generation HB Virtual Series. Now, with Petronas, they are trying to see how they can take the upstream work. This is where they do highly complex quantitative interpretation, seismic processing. And these workloads really need massive memory bandwidth. They need the capability of high-performance computing. And this is where Petronas worked with Azure, and we worked very closely actually with AMD to make sure that we could bring these new VMs. We could actually combine that with a lot of our AI tools and really accelerate the work that they are doing in geophysicists there and help them make decisions faster. Along with performance, though, Petronas also has a commitment to get to a corporate sustainability objective. And with Azure, because we are going to be 100% renewable energy by 2025, we not only allowed Petronas to actually get to their performance objectives, but we are also getting them to be able to get to net zero carbon emissions by 2050 for them. All in all, what this means is as customers look to performance, scalability of cloud, they can really benefit from the offerings that we have. This was on the HPV4. Now, if I look at the HX series, the newly announced HX series, I want to talk about ST Micro. So ST Micro is a leading semiconductor company, and they are actually the first ones to use our Azure HX virtual series. Again, this is a brand new offering from us, and ST Micro is going to use this for designing their next generation of chips. So a lot of their RTL simulations. Now, RTL simulation, especially as the process technology becomes deeper and deeper, requires much lower memory latency and large memory footprint, which is perfect for HX series. So what HX allowed ST Micro to do is they were able to pack in a lot more of their simulation jobs in each VM, which in turn meant they needed fewer VMs, they could do it far more efficiently. With their recent experiments that they have done, ST Micro has been able to save their simulation time down by 30%. So what that means is, their silicon engineers can actually look at a lot more design possibilities. They can improve product quality because they're now doing a lot more validation. But ultimately, they can bring products to market faster. And they don't have to worry about anything. They can do all of this in cloud because of our collaboration. So.
Yes, that's just fantastic. So it's great to see not only HBV4 come to life, but see the customers adopting across industries.
Absolutely.
So really exciting, and we can't wait to help grow this going forward. And I just want to say thank you for the partnership, and thank you for coming to see us today.
Yeah, well, thank you for having me here.
Thank you.
Yep.
Okay, another just great example of how we're partnering with our customers to deliver better solutions for our end customers. So VMs based on Genoa X are now available with Microsoft's HBV4 and HX VMs, empowering companies to bring the most innovative products to market. So Genoa X is just one example of how we're optimizing for different workloads. And you also heard more about Genoa and Bergamo today. Our final piece of the Zen 4 portfolio is Sienna, which is optimized for telco and edge workloads. Sienna will deliver maximum performance and energy efficiency in a cost-optimized package. And we will tell you all about this later this year. We'll bring that to market in the second half of the year. So now let me turn it over to Fars Narad to talk about how the modern data center is evolving and what that means for data center infrastructure. Thank you.
Thanks, Jen. Thanks, Dan. AMD is delivering the industry's best set of workload-optimized CPUs. But beyond the CPU, the workload-optimized data center needs to be one where every high-value workload is supported by high-performance engines, is energy efficient, and is agile, meaning it is easy to deploy, manage, and secure. That's our vision of the data center. And I'd like to bring on Jeff Marone of Citadel Securities to talk about their workload-optimized data center built with AMD. Jeff, welcome. Jeff, thanks for coming, and maybe you could tell us a little bit, first off, about Citadel and Citadel Securities.
Absolutely, Forrest. So Citadel is really two firms. First, we are the world's most profitable hedge fund, managing about $60 billion. But Citadel Securities is the world's largest market-making firm. So this is where I work and what I'm here to talk about. What does that mean? So as a market-making firm, we provide buyers and sellers, financial investors, opportunities to buy or sell any asset at a competitive price. And we do this at massive scale. So on any given day in the US equities market, 25% of shares that change hands pass through one of our systems. We do that for equities, options, ETFs, treasuries, and a variety of other assets at exchanges around the world. So now if you think about us from a technology perspective, it's best to think of us as real-time predictive analytics. We develop complex pricing models that predict where the market's going, sometimes to the millisecond or microsecond scale. And then as quickly as possible, we deliver those prices to the market. Now there's really two technology platforms that underpin this business, two platforms with very, very different workloads. First, there's a computational research platform that we use to develop these strategies and test them. And then there's an ultra-low latency platform that we use to respond very quickly to buyers and sellers in the market. Underlying both of these platforms, there's a complex monitoring layer to make sure that those models are always performing safely and effectively in the market.
Great, great. Thanks for the overview. And now let's dive into each one of those. Tell us more about the research platform.
Yes, so let's talk about research. Research for us means developing hypotheses about where market prices are going, expressing those hypotheses in code, and then testing them. But here's the catch. Testing for us means releasing those strategies in a simulation of the entire market and seeing how they perform under a variety of different environments and scenarios. And so the compute platform that we need to do this demands enormous scalability and a real focus on workload optimization. So, as an example, all of this research, which runs in the public cloud, reaches a peak demand of about 1 million concurrent cores and relies on a market data archive of nearly 100 petabytes. In late 2020, we transitioned all of that workload to AMD and saw a 35% improvement in research performance.
Fantastic.
And so here is where EPYC's innovation, particularly in memory bandwidth, has truly unlocked a different level of performance for our business.
That's fantastic. That's an enormous problem at a very impressive scale. There are not many workloads that require 1 million concurrent cores. And we're proud that you've trusted us with that and that EPYC provides you that performance boost. Now, tell us about the trading platform, because I think that's a little bit different story.
Very different, very different. So here's where we're vastly different. And I would say the polar opposite of many of the hyperscalers we heard from just a few minutes ago. So densification and virtualization are simply not welcome in this platform. And in fact, we invest massive resources internally and with AMD as our partner to take microseconds, nanoseconds, and soon picoseconds off our latency. And every one of the cores that run in this platform run in some of the most expensive data center real estate in the world. Expensive because it is as physically close as possible to the centers of financial markets. Right. So here is where our AMD partnership is also essential. If there is a packet of market data that is passing through that platform, it is guaranteed to go through a SolarFlare NIC. And for the most latency-sensitive strategies that we run, Xilinx FPGAs are absolutely essential. Quite frankly, they bring to market strategies and models that otherwise would never see the light of day.
You know, Jeff, Citadel Securities is obviously a great example of the theme that we've been talking about, which is workload optimization and the need for workload optimized solutions. And you certainly have two very different problems.
Yeah, absolutely. And in research, we look very similar to a hyperscaler, but in low latency trading, we look about the opposite.
Right.
And AMD has done an excellent job of understanding complex, multifaceted customers like Citadel Securities. And I look forward to continuing to innovate on products that make a difference for our business and improve how financial markets function.
Well, thanks very much, Jeff. Thanks for being here today, but more importantly, thanks for the trust and partnership over the years.
Thank you,
really
Forrest.
appreciate it.
Yeah.
Thank you. So now Jeff just told us how 1 million cores of EPYC CPUs in the cloud deliver optimized performance for the research simulations and trading strategies, and how Alveo FPGAs deliver the ultimate in performance for their trading and market-making systems. But he also introduced you to another important aspect of AMD in the data center, which is our network portfolio. For Citadel, this means high-performance SolarFlare NICs, giving them the ultimate in low latency and high performance to power millions of stock trades per day in a highly competitive marketplace. Together, computing and networking engines are becoming increasingly important to optimize together to deliver the performance, efficiency, and agility needed in that optimized data center. And so at AMD, we recognize that networking represented an increasingly critical element of the data center infrastructure that needed to be optimized for data center workloads. And that's hence motivated our acquisition of Pensando. Because the complexity of the data center continues to evolve. And the latest step with hybrid cloud and the extension of cloud computing out to the edge is an incredibly important model, but the challenges that come with that model are significant. Now, the first challenge is inherent to a cloud. Virtualization gave us higher utilization and agility, but also introduced overhead to ensure that workloads are separated and secured. Further, network complexity has exploded as compute and storage systems spread across the data center and applications no longer run on a single system. Managing these distributed resources is complicated, and securing the data center is even harder with an expanding attack system and much more to monitor. And you've got to monitor, particularly without further taxing the systems. So today, we have a very complicated cloud environment. The agility of the cloud is paid for with overhead in each server, and typically separate appliances to provide infrastructure services. The CPU tax in many cloud deployments can be 30% or even more for the hypervisor and infrastructure software, and load balancing, security, and other appliances are a major cost and a pain point to manage. Some of the pioneers in cloud computing, you heard from one earlier today, recognized the complexity and overhead that was being introduced by the architecture and created the concept of the DPU. AMD and our Pensando team evolved the concept of the DPU beyond a sea of cores to the world's most intelligent data flow processor. What I believe is the best networking team in the industry, the team we acquired with Pensando, stepped back and took a fundamental look at the problem and created a purpose-built architecture to be able to provide complex services, including security, software-defined networking, and telemetry at line rate, while simultaneously being programmable to accommodate customers' differing needs and to future-proof the architecture. Now, if we put this P4 DPU into each server, we can free the CPU from its overhead. With a DPU in each server, we offloaded the virtualization overhead and brought the infrastructure and security services to the point of use, eliminating or dramatically reducing the need for a set of external appliances, and further improving agility by simplifying management. Network and resource management of all of the servers are uniform. And perhaps most importantly, dramatically improving the TCO of the cloud by freeing the CPU resources to do what is really needed, run the workloads. Offloading that cloud and virtualization overhead is exactly why we first deployed our AMD Pensando P4 DPU in a SmartNIC, making it easy to add the DPU to each server and allowing us to tackle the overhead and freeing the server for productive use. But they also dramatically improve security by allowing new paradigms, such as firewall protection on all east-west traffic distributed across these distributed applications, encrypting all of that traffic, and finally, providing telemetry without taxing the CPU that allows security systems to have early warning of threats and anomalies in the network. I'm proud to say that AMD Pensando SmartNICs are deployed now in major clouds, and enterprises can get this solution today alongside of VMware vSphere Project Monterey. The SmartNIC has been a fantastic innovation. But as we worked with data center innovators across the industry, we recognized that the value proposition of the DPU extends well beyond the SmartNIC. The same DPU silicon and software platform is now being deployed in the infrastructure itself, where many of the same performance, efficiency, and agility benefits can be shared amongst a group of servers. And there is another bonus to this approach. This can just as easily be deployed into an existing infrastructure as well as designed into a new one. A great case in point for this is Microsoft Azure's Accelerated Connection Services, which is in public preview today and is powered by our Pensando P4 DPUs, providing dramatically higher connections per second and network performance for customers embracing that capability. And we're very excited about that. And so now we're bringing that same concept to the enterprise, the Smart Switch. Developed with our partners at HPE Aruba, it's an innovative switch built on industry-standard switching silicon and AMD P4 DPUs. Traffic flows through the DPUs to deliver offload, infrastructure, and security services that provide the data center not just better efficiency, but enhanced security and observability. And those benefits can be realized well beyond the walls of the data center into the myriad of edge computing applications that depend on security, performance, and agility. Deploying the same architecture and software platform at the edge means that the endpoint has a common level of security and manageability with its counterpart servers back in the data center. And those connections between the data center and the edge are as secure as possible. So putting it all together, you can deploy a few servers at a retail location with smart NICs providing security and manageability consistency to everyone. With Sienna EPYC CPUs providing transformative energy efficiency and performance, and Alveo inference accelerator cards powering latency-sensitive AI applications to enhance the retail experience and security. The full AMD portfolio can provide similar benefits to telco deployments, smart city applications, amongst many others. And so I hope that in this first half of our presentation, we've given you insights into how AMD is helping our customers evolve their data centers and make them more efficient, both in the cloud as well as in the enterprise, with workload-optimized solutions that address the most pressing problems of the hybrid cloud and edge. Next, let me invite Lisa Su back to the stage to discuss how we're helping our customers address their next evolution in the data center, incorporating AI into all they do. Thank you.
All right, thank you, Forrest, and thank you, Jeff, and thanks to Dan and Nidhi as well. Okay, so there's incredible interest in AI across the industry, and this is also, when we look at it, AI is really the defining technology that's shaping the next generation of computing, and frankly, it's AMD's largest and most strategic long-term growth opportunity. Now, in AI, we're focused on three key areas. First, it's delivering a broad portfolio of high-performance GPUs, CPUs, and adaptive computing solutions for AI training and inference, spanning across data center, edge, and intelligent endpoints. Second, it's developing an open and proven software platform to enable our AI hardware to be deployed broadly and easily. And third, it's really working with the industry, and it's expanding the deep and collaborative partnerships we have established to really enable the ecosystem to accelerate AI solutions at scale, because in this space, it's all about the ecosystem. Now, when you look at where we are today, we're actually very uniquely positioned with a broad portfolio of AI platforms across data center, edge, and endpoint. And that's powered by a number of engines. That's powered by our Ryzen AI engine, our Versal, our Alveo, our EPYC, and of course, our Instinct accelerators. Now, looking at where we're deployed today, it's really in many, many different places. So if you look at the edge, for example, NASA uses our leadership FPGAs on the Mars rovers to accelerate AI-based image detection. When you look at automotive, Daimler, Veoneer, Subaru, these are just some of our customers that are using AI silicon and software to power their driver assist and advanced safety features. In healthcare, leaders like Clarius are using AMD adaptive SoCs for faster AI-based imaging and solutions to really allow doctors to make quicker and more accurate diagnoses. And industrial, customers like ABB are using our technology for AI-assisted robotics. And Kakao Cloud is using many of our products for their vision applications, such as AI-based privacy and road systems. And earlier this year, we launched our Ryzen 7040 series CPUs, the industry's first x86 processors with a dedicated AI engine. And these have been ramping nicely, and we expect more than 70 Windows PC designs from the top OEMs to launch later this year, powered by Ryzen AI. So when you look at all that, there's no question that AI will be the key driver of silicon consumption for the foreseeable future. But the largest opportunity is in the data center. And over the last 6 months or so, the broad adoption of generative AI with large language models has really taken this growth to a different level. So people keep asking me, what is the opportunity, Lisa? What is the opportunity? What I'd like to say is, look, we are still very, very early in the life cycle of AI. I mean, there's so much opportunity for us. But when we try to size it, we think about the data center AI accelerator TAM growing from something like $30 billion this year, over 50% compound annual growth rate to over $150 billion in 2027. And it may be higher, it may be lower. But what I can say for sure is it's going to be a lot because there's just tremendous, tremendous demand. Now, AMD has been investing in the data center accelerator market for many, many years. And today, if you look at where we are, we power many of the fastest supercomputers in the world that are using AI to solve some of the world's biggest challenges. For example, at Oak Ridge National Labs, this is the #1 supercomputer in the world. It's the industry's first exascale supercomputer in Frontier. They're running large AI models on AMD Instinct GPUs to accelerate their cancer research. In Finland, the Lumi supercomputer uses AMD Instinct GPUs to power the largest Finnish large language models with 13 billion parameters. And we're also collaborating with researchers at the Allen Institute who are also using Lumi to create a state-of-the-art, fully open LLM with 70 billion parameters that will be used by the global scientific community. Microsoft actually uses EPYC and Instinct processors, and they've built the 11th fastest supercomputer on the recent top 500 list to run AI and HPC workloads. And we're also working with a number of other companies, like Korea Telecom, on their 11 billion parameter large language model. So let's just take a deeper look at how Lumi is using EPYC CPUs and Instinct accelerators for AI.
Cancer is one of the major burdens for human health. It takes a long time for the pathologist to go through one sample.
The aim of Combat AI is to build this decision support tool for pathologists to help them make the diagnosis. We show millions and millions of tissue samples taken from patients to this neural network. The more data you feed, the better the model becomes.
It takes a lot of compute to crunch that data and develop insights that we can use to advance humanity.
So the major challenges in analyzing these tissue images is, of course, a lot of this technical variation that arises from preparing these samples, like fixation and cutting and staining. And this, of course, poses challenges in training these neural networks. So with these AI-based decision support tools, we are able to provide pathologists with a tool for them to base the diagnosis on the data.
The supercomputer we built is going to help people to build more accurate and better models, get better outcomes.
We're impacting the lives of billions of people.
It's just one of the many stories of how people are using AI to really accelerate sort of next generation systems. Now, to enable generative AI, you need both best-in-class hardware, but we also need a great software ecosystem. So let me now invite AMD President Victor Peng to the stage to share more about the growing software ecosystem for our AI solutions.
Thank you, Lisa. Good morning. It's really great to be here. Many of you may have attended our Financial Analyst Day just about a year ago, and I had the great pleasure to talk to you about our vision of pervasive AI. So it's great that I'm here now, just about a year later, to share where we are and where we're heading in terms of software. And it's especially exciting for me, not only because now we've really put all the focus of the company under one roof, the data center GPU team, and our newly formed AI group, but really talking to customers and partners and really seeing how we could really help them realize this tremendous opportunity everybody sees and also solve some of the most challenging problems. So really super excited about that. And I can sum up our direction and the current state of things right now and how we're enabling AI and software development with 3 words: open, proven, and ready. Now, while this is a journey, we've made really great progress in building a powerful software stack that works with the open ecosystem of models, libraries, frameworks, and tools. Our platforms are proven in deployments today, as you heard from Lisa, and Frontier and Lumi, these massive scaled-out operations. And the demand for our platform is simply gaining tremendous momentum, and we are ready to meet that. So before I focus on the software and the ecosystem, I'd like to share with you some of the progress we've made on our platforms. At CES, we announced the Ryzen 7040, and as Lisa mentioned, it was the first x86 CPU with an integrated AI accelerator, which is our XDNA AI engine. The 7040 is now in production with features like video collaboration through the Windows Studio effects and Onyx runtime support, which was announced at the recent Microsoft Build event. In the embedded space, we're sampling the Versal AI products to leading customers in multiple markets, including markets like automotive and industrial. And for our EPYC platform, our latest ZenDNN 4.0 release is integrated with TensorFlow and delivering very significant performance improvements on AI workloads. Now, moving to data center GPUs, we're working with leaders like Microsoft and other leading cloud service providers, as well as many nimble, very innovative small companies. And we're seeing demand for our GPUs grow tremendously, and quite broadly as well. So now Lisa's going to talk about the MI300 in a little more detail later, so let's move on to software. Realizing application performance really does require a leadership software stack optimized for the ecosystem. Let me first cover ROCm, which is the software stack we have for our Instinct data center GPUs. ROCm is a complete set of libraries, runtime, compilers, and tools needed to develop, run, and tune AI models and algorithms. A significant portion of ROCm stack is actually open. Our drivers, language runtime, tools like our debugger and profile, and our libraries are all open. ROCm also supports the AI software ecosystem, including open frameworks, models, and tools. Now, ROCm is actually in its 5th generation, and it includes a very comprehensive suite of optimizations for AI as well as high-performance computing. And for examples on the AI side, we have optimized kernels for large language models. We have support for new data types like FP8, and support for technologies like OpenAI's Triton. The ROCm stack includes tools that allow easy porting of existing software to AMD Instinct platform. Now, to ensure the quality and the robustness of ROCm, we run hundreds of thousands of framework tests nightly, and we validate across a broad range, thousands of AI operators and end-to-end models. Now, this provides a very sound foundation for continued PyTorch and TensorFlow compliance, which enables a really rich out-of-the-box AI experience. So now let's move up the stack to frameworks, and specifically PyTorch, which is one of the most popular and growing framework. And what better person to do that than to have one of the founders of PyTorch talk about the collaboration AMD and PyTorch are doing to advance AI. So I'd like to introduce Sumit Katala to the stage to talk about PyTorch. Sumit, it's really great to see you. Thank you for coming.
Absolutely.
So why don't we start off by you giving us a high-level overview of PyTorch and the highlights of the latest iteration, PyTorch 2.0.
Sure thing. PyTorch is one of the more popular AI frameworks in the industry. It's used by several companies that you'd be familiar with. Meta, obviously, is one of its biggest users. There's OpenAI, Tesla. Almost like everyone in the industry probably uses PyTorch in some form if they're using AI. And PyTorch is the fundamental software through which most of the AI like neural networks, training, and inference happens. And we recently released PyTorch 2.0, which builds a compiler that gives you speed-ups like about 50% to 100% faster over like the out-of-the-box PyTorch before. And it's powered by OpenAI Triton, the technology that Victor talked earlier. And we're pretty excited about it. We're seeing a lot of customers being super happy about it. And that's PyTorch for you.
Yeah, thanks. And those innovations you just talked about with the significant speed up, we're really excited about that too. And we're super excited about partnering together, working with the PyTorch Foundation as a founding member. So can you share some of your thoughts about the AMD and PyTorch collaboration?
For sure. The PyTorch and AMD collaboration goes way back, several years back. As Alexis, my colleague, talked earlier today, AMD and Meta have been collaborating in various forms, and PyTorch mostly came out of Meta. it's a multi-year collaboration. We've been giving AMD a lot of feedback on many aspects of like the ideal hardware and software to run AI workloads, and AMD and us have been partnering together to build the ROCm stack and a bunch of PyTorch operators and integration to robustly test the whole stack. And I'm pretty excited for the current support, especially like on the Instinct accelerators that ROCm enables. And I'm pretty excited about MI300 as well. I think like this is the start. I'm looking forward to like how customers end up like finding the maturity of the stack, but like we've spent a lot of time trying to like make sure it does come out right.
Yeah, we're really excited about MI300 as well as several others, so thank you for that. So how do you see the collaboration that we're doing together benefiting the developer community?
Sure. Yeah, this generally like in AI workloads, one of the things we have is we have a single dominating vendor, and when you write your workloads and you have to make them be supported by switching to a different hardware, there's a lot of work that goes into doing that. Like there's a lot of software work that developers have to do to like move your neural network workloads from one platform to another. So one of the things that we've done with AMD, with the ROCm stack and the PyTorch integration, is you don't actually have to do that much work, or almost no work in a lot of cases, to go from one platform to the other. So you might do a little bit of tuning work once you deploy it onto your AMD GPU, but it's like super seamless. And so developers, I think, are going to have a huge productivity boost as they try to switch to like the AMD backend of PyTorch versus like the TPU or like NVIDIA backend. So I'm pretty excited about like the overall productivity developers would have when they're switching to the AMD backend overall. Like, and it's starting with the Instinct GPUs, and I'm hoping like you all enable it for like all of your other class of GPUs as well.
Absolutely, it's the goal to enable that capability to all the developers across all our platforms.
Yeah.
So thank you so much for the partnership. Really appreciate it.
For sure.
And look forward to more together.
Yeah.
Thank you. PyTorch 2.0 provides an open, performant, and productive option for developers to develop their latest AI inventions. And that option and that creativity and democratization, if you will, is super important. We are one of only 2 GPU platforms that is integrated with PyTorch at this level. OK, so we've covered ROCm and integration in open frameworks. That leads us to moving up to the top of the stack with AI models and algorithms. Hugging Face is the leading enabler of AI model innovation in the open source community. They offer an extremely wide range of models, including transformers that are at the heart of generative AI, but also vision models and models for all kinds of other applications and use cases. And this spans from multi-billion to almost trillion parameters to just millions and low single-digit billion parameter models. So here to talk to us more about their groundbreaking work and the partnership we have with Hugging Face is Clem Delange, CEO of Hugging Face. Please welcome Clem. Hey, Victor.
Hey, everyone.
Clem, it's great to see you. Thanks for coming. Why don't we just start off with share your thoughts about why open source matters for the growth and the proliferation of AI.
Thanks for having me. So first, it's important to remember that most progress in AI in the past 5 to 10 years has been thanks to open science and open source. Maybe we would be 50 years away from where we are today without it. Now, when we look to the future, open science and open source AI are not only a way to accelerate technology, but also to level the playing field and distribute to all companies, startups, nonprofits, regulators, the tremendous power of AI, the tremendous value creation of AI, and the tremendous productivity gains, right? In the future, we want every single company to be able to train and run their ChatGPT on AMD hardware, right? And all of that allows companies to build AI themselves, right? Not just to use AI through APIs, for example. By doing so, most of the time with customized, specialized, smaller models, it makes AI faster, cheaper, and better to run. It also makes it safer for the companies, but also for the field in general, because it creates more opportunities for transparency and accountability, which fosters more ethical AI.
Yeah, that's tremendous, yeah. It's so important to enable all those innovators and also promote that, responsibility and just the creativity of everybody and empowering them, like you said, to get it faster, better, easier to use. So just thrilled about that. So, and I'm personally thrilled that we just recently formalized our relationship. Can you share what the Hugging Face and AMD partnership is going to deliver?
Yes, we're super excited about this new partnership that we're announcing today. I think we can clap for that. So Hugging Face is lucky to have become the most used open platform for AI. Today we have 15,000 companies using our software, and they have shared over 500,000 open models, datasets, and demos. Like some you might have heard of, like Stable Diffusion, Falcon, Bloom, Starcoder, Music Gen that has just been released by Meta a few days ago. Over 5,000 models, 5,000 new models were added just last week. Just last week,
wow,
5,000 new models. I think it shows the crazy speed of the open source AI community these days. We will optimize all of that for AMD platforms, starting with Instinct GPUs, followed by Ryzen, EPYC, Radeon, embedded products like Versal and Alveos that we've heard about. We will also include AMD hardware in our regression tests for some of our most popular libraries like Transformers and our CI/CD to ensure that new models like the 5,000 that have been added last week are natively optimized for AMD platforms. That is super exciting.
Yeah, we can't wait till we have all those Hugging Face models across our entire portfolio, but starting with the MI Instinct. And that's amazing. 5,000 models in just a week. It's crazy. So what are your thoughts on the benefit of our partnership that's going to provide to the developed community and really the whole industry as a whole?
Yes, so the goal is to really have the best combo between hardware and software. Right? It's really important that hardware doesn't become some sort of the bottleneck or gatekeeper for AI when it develops. So what we're trying to do is to extend the range of options for AI builders, both for training and inference. I'm super excited in particular about the ability of AMD to power large language models in data centers, thanks to the memory capacity and the bandwidth advantage. Ultimately, AI is becoming the default to build all tech for all industries, right? From language models that we're talking about, but also image, audio, videos, right? We're seeing more and more time series, biology, chemistry, and many, many more domains. Hopefully, this collaboration will be one step, a great step, to democratize AI even further and improve everyone's life.
That is a truly inspired vision, and which we share at AMD. We deeply believe in that, and we're so excited that we're working together with Hugging Face to make that vision a reality. Thank you so much, Clint.
Thanks, Victor.
Really appreciate it.
Thank you.
Okay, with so many models being optimized on AMD, you heard that, and we'll soon be running right out of the box on starting with our Instinct platforms. We're bringing the power that you heard of the open source community, that speed of innovation, the breadth of models onto the AMD platforms. I mean, I think we all know that AI, the rate of innovation of this is unprecedented. The open source community is clearly a major driver of that rate and the breadth of innovation. And our software integration with and optimize for the open ecosystem to deliver a productive, performant, and open development stack is vital to that. Our platforms are proven at scale in production deployments, and AMD is ready to help our customers and developers achieve the next breakthrough in AI. Thank you so much, and now I'd like to invite Lisa back to the stage. Thank you.
All right, thank you, Victor. And a very, very special thanks to Sumit and Clem for joining us today and talking about our partnership. No question, the software ecosystem is so important for enabling our hardware to be deployed more broadly. I would say it's a journey, and we know it's a journey, but we've made a tremendous amount of progress over the past year with ROCm and the most important frameworks like PyTorch, TensorFlow, and Onyx, and also really expanding our collaborations with key model developers and distributors like Hugging Face and many of the other open source models out there. Now, we always like to save hardware for last, so turning to AI hardware, let me say, the generative AI and large language models have changed the landscape, okay? The need for more compute is growing exponentially, whether you're talking about training or, frankly, whether you're talking about inference. Larger models give you better accuracy, and there's a tremendous amount of experimentation and development that's coming across in the industry, and you heard that from both Sumit and Clem. At the center of this are GPUs. GPUs are enabling generative AI, so now let me turn to our Instinct GPU roadmap. CDNA is the underlying architecture for our Instinct accelerators. It's designed specifically for AI and HPC workloads. CDNA 3 is our brand new architecture that uses a new compute engine, the latest data formats, 5 and 6 nanometer process technology, and the most advanced chiplet packaging technologies. At CES earlier this year, we previewed MI300A. It's the world's first data center APU. And what we have is our CDNA 3 GPU architecture with 24 high-performance Zen 4 CPU cores. Now, these are the exact same cores in our leadership Genoa processors that I talked about earlier in the show. And we also add with that 128 gigabytes of HBM3 memory, all in a single package. And what we have is unified memory across the CPU and GPU, which is frankly very effective, particularly for some HPC workloads. Now, this results in 8 times more performance and 5 times better efficiency compared to the MI250X accelerator that is in the largest supercomputers today. Now, MI300A has also been designed into supercomputers already, and it's slated for the 2+ exaflop El Capitan system at Lawrence Livermore National Labs. It's the most complex chip we've ever built, with more than 146 billion transistors across 13 chiplets. Now, you guys know we've led the industry with the use of chiplets in our products. And our use of chiplets in this product is actually very, very strategic. We created a family of products. So in addition to the MI300A product, with our chiplet construction, we can actually replace the 3 Zen 4 CPU chiplets with 2 additional CDNA 3 chiplets to create a GPU-only version of MI300, optimized for large language models and AI. We call this MI300X. Now, for MI300X, to address the larger memory requirements of large language models, we actually added an additional 64 gigabytes of HBM3 memory. So with that, Drew, I am super excited to show you, for the very first time, MI300X. Now, for those of you who are paying attention, you might see it looks very, very similar to MI300A, because basically we took 3 chiplets off and put 2 chiplets on, and we stacked more HBM3 memory. But what you see with MI300X is we truly designed this product for generative AI. It combines CDNA3 with an industry-leading 192 gigabytes of HBM3 that delivers 5.2 terabytes per second of memory bandwidth, and it has 153 billion transistors across 12 5-nanometer and 6-nanometer chiplets. So I love this chip, by the way. We love this chip. So look, when you look at the world, there are many things that you need. You need great compute engines, but you also need a lot of memory for everything that's going on. So when you compare MI300X to the competition, MI300X offers 2.4 times more memory and 1.6 times more memory bandwidth. And with all of that additional memory capacity, we actually have an advantage for large language models because we can run larger models directly in memory. And what that does is for the largest models, it actually reduces the number of GPUs you need, significantly speeding up the performance, especially for inference, as well as reducing total cost of ownership. So, of course, I want to show you the chip in action for the very first time. So let's watch MI300 in action, shall we? For this demo, we wanted to show you a large language model running real-time inference on a single GPU. And since we had Hugging Face here with us, we're actually going to run the recently released Falcon 40B foundational large language model, which is currently the most popular model on Hugging Face right now, featuring 40 billion parameters. So let's watch, for the first time ever, MI300X running Falcon on a single GPU accelerator. All right, let's start. We have to give the model a prompt. So we are here in San Francisco. Let's say, write a poem about San Francisco. Here we go, the poem's coming. You can see it's responding in real time. I'm not a great poet. I don't know about you guys. The city of dreams that always keeps you yearning for more. I would say that poem's pretty good, huh? Now, look, you guys have all used generative AI already, and you've seen a number of generative AI demos in the past few months. But what I want to emphasize that's special about this demo is it's the first time a large language model of this size can be run entirely in memory on a single GPU. We've run a number of even larger models, including Meta's 66 billion OPT model, as well as the 65 billion Llama models. And if you just look using FP16 inferencing, a single MI300X can run models up to approximately 80 billion parameters. So what does this actually mean? If you look at the industry today, you often see that, first of all, the model sizes are getting much larger, and you actually need multiple GPUs to run the latest large language models. With MI300X, you can reduce the number of GPUs for this, and as model sizes continue growing, this will become even more important. So with more memory bandwidth, and fewer GPUs needed, what this means for cloud providers as well as enterprise users is we can run more inference jobs per GPU than you could before. And what that enables is for us to deploy MI300X at scale to power next-gen LLMs with lower total cost of ownership, really making the technology much, much more accessible to the broader ecosystem. And what that also means is that not only do we believe that we have better total cost of ownership, but we've also been able to significantly reduce the amount of development time needed to deploy MI300X. Our goal with MI300X is to make it as easy to deploy as possible. And what that means is the infrastructure is also incredibly important, which is why I'm also excited to announce the AMD Instinct platform. And what we're doing with this platform is, again, we're all about open infrastructure. So what we're putting is 8 MI300Xs in the industry standard OCP infrastructure. And for customers, what that means is they can use all of this AI compute capability and memory of MI300X in an industry standard platform that drops right into their existing infrastructure with actually very minimal changes. And with this leveraging of OCP platform specification, we're actually accelerating customers' time to market and reducing overall development costs while making it really easy to deploy MI300X into their existing AI rack and server infrastructure. So to sum it up, let me give you a few key takeaways. First of all, we're incredibly excited about AI. We see AI everywhere in our portfolio. With MI300X, what we offer is leadership TCO for AI workloads. We're really focused on making it easy for our customers and partners to deploy, so that Instinct platform really lowers the barriers for adoption. And frankly, the enterprise-ready software stack, we know that this is so important. We've made tremendous progress through our work with the frameworks and the models with our partners, and there's going to be a lot more that's going on over the next many years in this area. Now let me talk about availability. So I'm happy to say that MI300A began sampling to our lead HPC and AI customers earlier this quarter, and we're on track to begin sampling MI300X and the 8-GPU Instinct platform beginning in the third quarter. And in addition, we expect both of these products to ramp in production in the fourth quarter of this year. So I really look forward to sharing more details on the MI300 family when we launch later this year. Let me wrap things up for today. We showed you a tremendous amount of new data center and AI technologies from our expanded portfolio of leadership EPYC server processors with Genoa, Bergamo, and Genoa X, to our industry-leading DPUs and SmartNICs, to our expanding AI software ecosystem, and our next-generation MI300X data center AI accelerators. It is just an incredible pace of innovation, truly exciting. But what's more than that, we really appreciate the partnership with our partners, and a very special thank you to our partners who are here with us today: AWS, Meta, Microsoft, Citadel, PyTorch, and Hugging Face. We truly believe in co-development, co-innovation, and partnership. It's been a great day as we take another major step forward to make AMD the data center and AI partner of choice. Thank you so much for joining us.
好的，发布会比较长，看得我都发困了。但是呢，确实这里边东西还是不少。除了刚才说的这个 APU 之外啊，AI 芯片之外呢 ，AMD 还发布了它的第4代 EPYC， 就是骁龙处理器。那么包括亚马逊、微软、Meta 在内呢，都表示可能会选用 AMD 的新品。有竞争啊，总归是好事儿，是吧？在英特尔看起来这个不显山不漏水的这个慢慢落后的情况下， AMD 和英伟达开始先锋点水。那么我们看到这里边呢，这个视频里内容还是很多的，那大部分呢有一些专有名词是看不懂啊，总之是很神奇吧。可能大家过去对 AMD 的印象还是高发热耗电，现在呢 AMD CPU EPU APU 已经提高的很快了。不少朋友的电脑里边可能还是老的 AMD 的芯片和显卡，那现在呢看起来呢新的机会来了，高端用户可以升级你们的电脑了。那好的，关于 AMD 的新品发布会它的 APU 情况呢和大家介绍到这儿这一期 AX 呢感谢大家收看。如果你喜欢我们的频道的话呢，请您关注、留言、点赞和转发。咱们下次再见，拜拜。